Enzymes are biological catalysts that speed up reactions, but there are certain factors which determine how good they are at their job or how effective they are. So temperature is an important factor when it comes to how well an enzyme works. That's why I'm down here on the beach where it's nice and warm. And each enzyme has a temperature that it works best at, which we call its optimum temperature. So enzymes decrease the activation energy of reactions so that these reactions can happen at rather low temperatures. And as body temperature is around 37 degrees, most enzymes have an optimum between 37 and 40 degrees C. Above 40 degrees C, and you're determined to have a temperature and be unwell because it's rather unusual to be operating at 40 degrees C. So let's take a look at this graph. At the start of the reaction, the rate of the reaction increases proportionately with the rate of the temperature increase. That's because particles are moving quicker as they've got more thermal energy. If they're moving quicker, there are more collisions, which means that there are more enzyme-substrate complexes being made. That's where the enzyme and the substrate join together, which means there's more reactions and more product being made. Then in the second part of the graph we reach the top of the curve where it's at its optimum temperature. This is where the reaction's working as fast as possible. And in the third part we can see that the reaction stops very quickly as the enzyme denatures as the temperature and the thermal energy has got too high. And as we know, enzymes are large proteins. They're made up of lots of amino acids, and as the temperature increases, it disturbs the bonds that join those amino acids together, which means that it changes the shape of the protein. And if it changes the shape of the protein, then it also changes the shape of the active site. This is denaturing. If the shape of that specific active site is changed, it can't bond with its substrate anymore, which means that the reaction cannot occur despite how many collisions it might have with that substrate. To explore a protein denaturing, it's useful to look at something that we're familiar with. An egg white is majority protein, so let's take a look. And as you can see, when it's straight from the egg white isn't so white. It's more clear and sticky and gooey in texture. Okay, so I've added some butter to a hot pan and then we've put the egg in, and you can see quite quickly that clear egg white actually turning opaque and white and rubbery. And that's the protein in the egg white denaturing. Denaturing is an irreversible reaction where you cannot change it back to the way the protein was before. And know this, denaturing is not killing the enzyme. The enzyme was not alive to start with, so do not say that the enzyme has died, it is denatured. The other thing that affects an enzyme is pH. Now pH is the percentage of hydrogen ions that are free in a solution, and because each one of these hydrogen ions carries a charge, it means that it can disrupt the bonds between the amino acids in the protein, which makes up the enzyme. Once again, if these bonds are disrupted, then the enzyme shape can change, which means that the active site can change. So if the active site isn't the specific shape for its substrate, then the reaction won't happen. And so a graph for pH is a lot more balanced than the graph for temperature when we're looking at an enzyme reaction. But we can still split it into different sections, and you can see the optimum at the top of the curve, and either side you can see it's straying away from the optimum and the enzyme denaturing when the pH is too low or the pH is too high compared to the optimum pH that the enzyme is meant to work in. And different enzymes work in different pHs. Stomach acid is about pH 1 to 2, and things like pepsin work in there. However, enzymes such as amylase like to work in pH 7, like the pH of saliva. And now it's time for Mr. T's top tip. When looking at a graph of an enzyme reaction, split it into 3 sections to describe it. The first section is talking about enzyme collisions increasing, increased enzyme substrate complexes forming, so more product being released. Section 2 is the optimum, where the enzyme works at its fastest rate. And section 3 is looking at the denaturing of the enzyme, where the shape is changing and the shape of the active site has changed so it can't work anymore. So enzymes really are these amazing little molecules that help you live. If you're too cold, you die. And if you're too hot, you die. So you need to be at your optimum. Why not check out more of our videos or even our Cyber 60s for a shorter 60-second version. And if you found this Cyber Teachers video informative and helpful, why not click like and subscribe, and we'll keep the Cyber Teachers content coming.